both magnitude and direction is a vector represented by an arrow. The arrow's direction is the direction of the quantity, and the length of the arrow indicates its magnitude. Displacement, velocity, and acceleration are all vectors. In equations, vectors are written in boldface. Ordinary quantities such as time and mass are scalars. In equations, scalars are written in italics. The magnitude of a vector is also a scalar, the same letter, but in italics. With vectors, even the most familiar mathematical operations acquire an entirely new meaning. For example, when two vectors are added together, the sum isn't merely a number, it's a new vector. Also, vectors can be subtracted from each other, and the result is another new vector. A vector can be multiplied by a scalar. This new vector has the same direction if the scalar is positive, but its magnitude can be different. Multiplying a vector by a negative scalar reverses its direction. A vector can be multiplied by another vector. The dot product of A and B is a scalar that measures the tendency of the two vectors to point in the same direction. A dot B is equal to the length of A times the length of B times the cosine of the angle between them. If A and B are perpendicular, their dot product is 0. And the dot product of a vector with itself is just the square of its length. The cross product of two vectors is a new vector, perpendicular to the plane of the two original vectors. Its length is the area of the parallelogram formed by the original vectors. Its direction is determined by the right-hand rule. The cross product measures the tendency of two vectors to be perpendicular, and it's one of the more effective tools for describing spinning or rotating objects. Vector algebra makes use of two perpendicular unit vectors, I and j. The little hat over the vector means that it has length 1. The vector from the origin to the point with coordinates x, y is the sum of two perpendicular vectors, a horizontal vector xi and a vertical vector yj. With the help of I and j, adding and multiplying vectors can be accomplished by ordinary algebra. Three-dimensional space, a third unit vector k is used. K is perpendicular to the plane of I and j. A three-dimensional vector is written xi plus yj plus zk.